Hey all, Brad here with another video, two in one day here, and I'm supposed to be working on my own games. But a good customer of mine, Dylan, had sent me a message on Clove about needing a new widget board, an I/O board for the Williams games, one of the standard ones used on Stargate, Joust, Sinistar, Bubbles, etc. And I've got a bunch of old boards that I bought over the years, hundreds and hundreds of Williams boards. So I said, yeah, sure, I could pull one out, go through, completely restore it, replace all the components that I normally do, test it, and get it out to you in a day or so. I'm gotten pretty proficient at going through these. So that's what I've got on the bench, and I thought I'd share with you guys. I may have done it in another video, but how I test them. I think I've showed before that I do use a Sony PlayStation controller that I have the ability to map to all different games through a microcontroller. And what I also did with that same microcontroller is program where when I load that code, if I hit the X button, it'll sequentially drive all the inputs to the I/O board, so I can test them one at a time, count them, make sure they're all present, and then I can clear that as well. So it's a great way. All the boards, regardless of the game that they're being used on, even if Joust does only uses a handful of the inputs, some of the other games only use different inputs. I test all 18 inputs. These boards have potential of 18. I'll talk about that here in a minute. So I test them all, so no matter what game it goes into, I know confidently that they're all working. So let me switch over to the bench cam. I'll show you what we did, talk about the board a little bit, and then we'll do some testing and wrap this up quickly, hopefully. Okay, so there's the bench cam. So here's an I/O widget board, and again, these have two 10-pin Molex headers on them, 0.396, which is zero point 0.2 inch spacing between each pin. This one I have upgraded from the round pin to the square pins. I do that on all the boards I work on. As those inputs come in, they go through some buffers here, basically to isolate your control panel in the game. They call electrically noisy from expensive components on here, like the PIA that talks directly back to the CPU over the address and data bus. And then these are a couple multiplexers to increase the count from 8 to 16 potentially here. So that's what those chips do. And again, these are just 4049 buffers. And then there's some other capacitors and filters, discrete components that are used, and pull up resistors to pull these up to 5 volts when they're not active. These are all activated when you pull them low to ground. So on here on the back, you'll see that pin 10 here on this one and pin 10 on this header are both connected to the ground plane. So 2 of the pins out of the 20 are dedicated for ground, and then you get 9 and 9 that are available as input, so you get 18 total on the board. And they use the standard ribbon cable. So what I do when I rebuild these, I'll show you the actual customers here. So it's got 2 new 10-pin Molex headers on it with the square pins. These are brand new connectors from Mauser, I believe. I've got a brand new 150 microfarad Nichicon 35 volt capacitor on here. Has more capacitance than the original, and a lower ESR. And it's a high quality, well recognized manufacturer as well. And then again, I make up brand new ribbon cables. These are 3M parts or NOS parts, Thomas Betts, or really good high quality stuff I'm only using. And then I go through, clean them, wipe them down. If anything's damaged, if they're really bad boards, I'll pull the labels off. I'm able to remove the labels without damaging them. Simple green bath the boards and then dry them. I do them in the oven and then reapply the labels and all that. This board was pretty clean to begin with. I selected one that I'd hope would be a quick and dirty one, which it was. Not dirty. Pun intended there. But these are the pull-up resistors, these 2 blue ones here. Straighten those out too. Sometimes they're bent over, kind of bugs me. So anyway, this board physically and everything has been gone through, and the last step was to test it on the bench. So what I use, the only game out of the Williams that used this board that used all 18 of the inputs is Splat. So I had made a Splat board. Again, Splat is the same board as Joust and Robotron, except it used SC2s, the custom blitters here. It was the later revision, which are harder than hen's teeth to find. I have the ability to convert SC1s over, and I have come in possession of a few SC2s original. So this is running original Splat code on a board, same MPU as Joust and Robotron and those ones used. So this is a real Splat board running, and I wrote my code that uses all 18 of those. So let me switch back over to the gameplay, and we'll boot it up and go through. Okay, so let me go ahead and power on here. A little remote control on the bench. Whoops. Nice carpet rug pattern. And again, this is going to be Splat. USA shirt. Tomorrow's the 4th of July. I mentioned that in a previous video, but so there it is, the attract mode for Splat. So again, with my PlayStation controller, I've already sent the configuration that I have, which is for Splat and specifically for testing the I/O widget board. So I'm going to drop into diagnostics here, test the ROMs, checks the checksums, then it goes into a RAM test. No RAM errors detected. Again, we're not interested in this because I'm focused on the I/O board. Test the CMOS RAM. Then it goes through and allows you to test the outputs from the ROM board that drive the soundboard. And then this screen is the switch test. So again, this is where we would be testing all the different inputs here, which I'm just cycling stuff on the controller. But what I did is I wrote a routine that when it senses the X come in, it'll run a sequence to drive every single input, including the ones that go to the ROM board. Some of the inputs go to the ROM board. So these ones here are all on the I/O board, and again, there should be 18. So it starts with walk up 1 down to throw right 2. So what I do is count those typically. So if you count walk 1 up, down, left, right, player 1 start, player 2 start, throw up, all those way down to throw right 2, you'll count 18. And then the ones on the top there, the right coin, the high score reset, left coin, center coin, slam switch, those are all coming into the ROM board. And there's also one more that's the advanced that takes you out of this menu that you see when I'll tap it, it'll leave the screen. And so what I can do now before I do that is I'll clear those. So if I hit the triangle button on the PlayStation, it clears all the inputs. It lifts them all, puts them back to floating. So the pull-up resistors pull them back to 5 volts. And then as I hit the X and run through the sequence again, it pulls each one down to ground. Programmatically in the microcontroller, what I actually do is when I hit the triangle button, I switch all the inputs or switch all of the I/O lines to inputs, so they float with a super high impedance, mega ohm. And then when I drive them, I actually change them to an output and then pull them low. So that's a easy way to do it programmatically. So again, clear these. We'll run it one more time. So again, I'm highly confident whatever game the customer, Dylan, puts this into is going to work for them because all 18 inputs are working. So that's just a quick video on how I test everything before it goes out. I do typically, anytime I do board work like this with ribbons and all that kind of stuff, I let it run on the bench for about, anywhere from 12 to 24 hours, ideally overnight. Usually I have enough stuff going on where I can get something on the bench here. I have a dedicated test bench versus the bench I do, soldering work and that with my exhaust fan and all that. So a lot of times I can just leave a board set or two running on the bench. Sometimes I'll hook up an oscilloscope where I'll monitor the pin 37 on the 6809 CPU, which is the reset, and make sure the watchdog hasn't triggered or anything like that. So I'll have a trigger that, let's say I go to bed at night and I'm monitoring the I put a trigger, set the scope up for trigger input on the reset line, and if it does trigger even once, I'll capture that and it'll be stored on the screen of the scope. So when I come down in the morning or when I get home from work the next day, typically I look at the scope and I want to see it blank. And if I see a little line there, I'm like, oh, it watchdog. Because if you don't do that, the whole purpose of that watchdog circuit is to, if the board encounters some sort of error, it'll force a reset, and then maybe times it'll clear up and it'll never happen again for a day or two, right? So that was the whole purpose, that these things would auto recover from a minor power glitch or a static discharge if a kid's dragging his feet around rubbing balloons on his head, who knows, right? But they were designed to be pretty robust and self-correct if possible. So if it did encounter a watchdog triggering a reset, before I send a board out, I want to know that it happened so I can correct it before going out. So anyway, I'm going to wrap this video up, and thanks for watching. Keep an eye out for the next one.